In this video, we're going to talk about cis-trans stereoisomerism, how to draw them and how to name them. Now, in the first picture we're going to show you, you can see these lobes, which are basically orbitals that are overlapping from two carbons. So this is a carbon here and this is a carbon here, and they overlap to form this sigma bond in the center. Now, you just need to know that that sigma bond is a single bond, and then the second bond in a double bond are these pi bonds, and they were formed through these p orbitals overlapping. And those pi bonds are above and below the plane. Again, that's in green because you have to add that into when you're describing the structure and bonding of the alkenes. You have to describe that the bonds are above and below, the pi bonds are above and below the plane. Now, if that is the case, okay, this started from having these p orbitals here, and these p orbitals are going to sideways overlap. And that's what they form. And you saw that in the video at the start. You can see they're molding together like this. And again, this is just the probability of the electron being in this space. So it could be anywhere within this space. Okay, and before it bonds, it can be anywhere in these spaces. So this is a p orbital because you can see it is a dumbbell. Now, if that is the case, if we look at it, leave that up here right now, okay, and we look at the formal definition that you need for your exam. So the double bond is formed as a result of the p orbitals overlapping to form a pi bond. You can add sideways overlapping as well to make it a fuller answer, okay, but it's really important you just say they're overlapping to form that pi bond. Now, if you're asked about the structure, say that the pi bond is above and below the plane of the, and you can say of the single bond, which is correct, but doesn't really get you any marks. And remember, okay, it contains two electrons. Really important, the sigma bond here has two electrons and the pi bond has two electrons. So there's a total of 4 electrons in a double bond. Okay, now that reaction that happens with alkenes, the pi bond breaks. So the sigma bond doesn't, the pi bond breaks. And we'll show you that in mechanisms when we've gone over them in videos. So here you have it. Just to go over it one last time, this sigma bond is this single bond, and then this pi bond above and below the plane of the sigma bond is the second bond of the double bond. Now, we're going to move on to stereoisomers and restricted rotation. So a stereoisomer is something that has the same structural formula with a different arrangement in space. So that's a definition, and you need to remember it. Okay, like I said, it's in green in these videos, and we'll leave it across the bottom just to keep it in your mind. Now, the isomers you've come across so far and will come across in the future are split into these sections. So structural isomers, and hopefully you remember that there are 3 types that we talk about, which is positional, when you move the functional group along the chain, and then you've got functional group, sometimes called group isomers, sometimes called functional group isomers, where you can change the functional group, for example, aldehydes and ketones, or cycloalkanes and alkenes, or ethers and alcohols. You can also do chain, where you just put branches into your structures and make isomers out of them. Okay, and your definition for that is just the same molecular formula with a different structural formula. Okay, but we're not going to talk about those today. We're going to talk about the stereoisomers. And the stereoisomers are split into 2 sections. So EZ and cis-trans on one side, which is alkenes, which we're going to talk about in this video. Okay, and optical, which we're going to talk about in further videos, usually in your second year of your A-levels. So let's focus on the bit we're going to do today, EZ cis-trans. And we're going to go over some examples. But before we do that, let's talk about EZ and cis-trans and what they mean. So everything has an EZ label, and we'll talk about these EZ labels and how we name compounds and molecules, okay, later in this video, but everything can be EZ. Now, cis-trans is a special section of EZ. So even if it is cis-trans, you can still call it EZ, for example. But cis-trans is a simple version, and EZ is usually used for the more complicated examples. And again, we'll go through all of these examples in the video. So if we put that to the side now, and we start going through cis-trans isomerism. Now, cis-trans isomerism, okay, is going to be the one where we have a carbon-carbon double bond present, like we've talked about in this video. And the cis-trans nomenclature, that's the way of naming, can be applied to any compounds in which two of the groups on it are the same. So, for example, two hydrogens, two chlorines, two OHs, two fluorines. It can be anything where the two groups are the same. And alkyl groups, doesn't matter what length they are considered just alkyl groups. So if you have an alkyl group of 1 carbon in length and you have an alkyl group of 3 carbons in length, they're still considered the same in terms of cis-trans, and you can call that molecule a cis-trans isomer. But you need that carbon-carbon double bond because of the restricted rotation, and that restricted rotation stops the groups flipping, okay? But it is not confined to carbon with hydrogen bond to each atom. So like I've said, it could be with 2 hydrogens, 1 on each atom. It could be with 2 fluorines, 2 OHs, 2 chlorines and things like that. But it's much easier to talk about this if you actually look at the examples, okay? And that's what we're going to do now. So if you look at the examples we're going to do a simple one, which is, there you go, and you've got 2 chlorines. So first of all, we've got a alkene with 2 chlorines on. Now, there is 1 chlorine on 1 carbon and 1 chlorine on the other carbon. That means we have 2 of the same group on each carbon, so it fits our second rule. We've got a double bond as well, fits the first rule, and we've got 2 groups that are the same. So this is dichloroethene. So this could be cis-trans because we've got 2 of these, or it could be cis-trans because we've got 2 of these. Okay, and they have to be on each carbon. There's 2 ways of drawing this. Remember the restricted rotation around here. So I could draw it, and it would be a different stereoisomer if I drew the chlorines either side, and then draw the hydrogens in. Okay, so we've got 2 molecules right here, and they are the same structural formula because they're made of the same building blocks, okay, but they have a different arrangement in space. So that arrangement in space is a chlorine up here, a hydrogen up here, and a chlorine up here. So it's different arrangements. So it fits our definition for our stereoisomers. So then we have to talk about what is cis and what is trans. Okay, so if you look at it, there's ways of remembering this. So I'm going to try and take you over the really, really easy way of remembering it. So the first thing is we've got cis. Now cis means that it's on the same side. So if you look here, can you see these are on the same side? So they're on that side of the double bond. Now, if it's on the same side, we call it cis. Okay? Now I'm going to teach you a little trick here. So we got cis, okay, and cis, and think about it as cis as the S means the same. So cis, same, okay? And that's an easy way of trying to keep it so that you can understand. And I'll go through other ways of E and Z as well in a minute. If you look at these ones, you can see that the chlorines are on opposite sides of the double bond, okay? Now, I'm going to go through a few words here. So first word is going to be transatlantic. If you're going on a transatlantic flight, you are going to go from a flight from one side of the Atlantic to the other side. So you're crossing the Atlantic. So we are crossing the double bond here. So we're crossing the double bond. So that word trans, so transatlantic, trans meaning crossing the Atlantic, okay, or trans meaning crossing the double bond, okay? So this one is going to be trans. All right. So what we can do is simply name these things and say, well, we know that that is ethene. Okay, and we know that the position is 1 and 2. So this would be cis, because it's on the same side of the double bond. And then 1, 2, di, and we've got 2 chloros, chloro, ethene. Okay, now if that's cis 1,2 dichloroethene, this would be trans. Okay, and that would be 1,2 dichloroethene. So what we've got here is two alkenes, both with the same structural formula and a different arrangement in space. Okay, same molecular formula as well and everything like that, but we've got two groups that are on each carbon that are the same, so we can call it cis, and they're the same side of the double bond. And then we've got these on a different side of the double bond, so therefore trans going across like transatlantic. If we then do this with a different one, for example, we're going to do it this time with but-2ene, and we're going to do it skeletally. So if you do it skeletally like this and you do cis, you see but-2ene, and you stop the video right now and try and do it yourself. So try and do it. So it's, I want you to draw cis but-2ene and trans but-2ene. So if you think about it, but-2ene is 4 carbons in length, and the but-2 is on the second carbon. So I'm just going to draw, there you go, skeletally. Okay, it's 1, 2, 3. Okay, and I'm going to go 4. Now, with the fourth one, I can either go up or I can go down. Okay, so I'm going to draw down, and that's my but-2ene, or I can draw another one, and I can go up. Okay, so I've got one going both down, and one where I'm going down, and one where I'm going up. Okay, so that basically means that this is on the same side. So these two groups that are on the double bond are on the same side. So this is cis but-2ene, and this would be trans. And that would be trans but-2ene. So just go back over our definitions, just to make sure you know. So we've got carbon-carbon double bond present. We've got two groups that are the same on each carbon of the double bond. So we can then do cis-trans. Okay, it's not restricted to hydrogen because we've got chlorines here, and we've got carbon compounds here, alkyl groups. Remember, alkyl groups, if they're different lengths, can still be considered the same, and we'll talk about other examples of that in a bit. But you can see here we've got skeletal formula where they're both pointing down. We've got a displayed formula where they're both pointing up, so it doesn't matter whether they're pointing up or they're pointing down. We've got going across here, which is trans, because transatlantic, for example, trans means cross. So we're going across the double bond, okay? And then here we're going across the double bond again for trans but-2ene. And that is how you draw simple cis-trans isomers for compounds containing different groups other than alkyl groups and compounds containing alkyl groups, and doing it with skeletal formula. Okay, in this example, we're going to stick to examples that don't have two hydrogens. So you can see here we've got two chlorines already drawn for you, and they're on the same side. So you say they're on the same side of this double bond, okay? And then we look at this one, we can see that the chlorines are across the bond. So they're across the bond, okay? So slightly different, but they're isomers of each other, and they're cis-trans isomers of each other. I've already written out the names, and the names are in alphabetical order. So we've got the B and then the C. Ignore the di, just the C. So it's A, B, C, and then F. Okay, so all the groups coming off have to be done in alphabetical order, and they're done from the earliest numbering system. So the earliest numbering system is 1 and 2. Quite easy on this one. Right, so all we have to do, right, is decide which one's cis. So the same side is going to be cis. So all you do is put your name at the start. Okay, and then just using different colours, and then we're going to go trans. Okay, and there you have it, and that is how you go about looking at cis and trans, but without two hydrogens, but two groups that are exactly the same, like the chlorine.